Welcome to another teardown video. Yes, this time it's another oscillator. I guess this is sine wave, right? And it's an HP model 200 CD. Wide range, what kind of range is that? Okay, so it goes from times 1, right? So times 1 is 5 Hz to 60 Hz. So if that is 60 Hz, then it's 600, 6K, 60 kilohertz, and 600 kilohertz. Oh, I really like this. So in case the accuracy is really that high, I am going to find out, of course, if it works. So we got ground 600. What is that? Differential? So, what if I want a single-ended signal? Can I just connect one of them to ground, or is it? I need to figure that out. And what have we got here? Amplitude from, is it 100 volts or 100 bananas or just 100%? I don't know. There are many ways to find out. Read the manual is one way, but I don't do that. I measure things. Click clock. And this is the back side. Ooh, I just measured. This unit is 9.4 kilos. For an oscillator. That is crazy. Yeah, and of course, voltage selector, fuse, serial label, yada yada. I'm looking through this, and what do I see? Is that tubes? Capacitors down there, maybe we got tubes. But we need to power it up first. So we are ready to power it up. Let me turn on the mains and there nothing happens. $35 and $20 and $19 and so there's definitely some warm-up. This could reveal. What the heck? 70 watts? It waked up. And it was saying some sounds and now it's 73 watts. Ooh, scary. I can really hear something, and I'm measuring output to ground, and I got 13 volts. It's not really reacting here, so I think I need to measure between those two. I'm worried about the sounds. Ooh. All right, so the amplitude is between the two outputs and not earth. And look at this. So it goes from 0, yeah, and full go, and this is 10 volts per division. So yeah, 65 volts peak. Ooh. That is some heavy juice. And that is 5 kilohertz, by the way. Look at the frequency, 5.0 something, right? And look at that. Really? How do they do this? So let's see how accurate we can put this to 6. Yeah, okay. 6. That is really nice. Let's go all the way back to 5. Okay, so this should be 500 Hertz, right? And let's, I mean, this is just crazy. Let me try and trim this way, right? Until we see 500. And then the idea is, so this is the error, 500 Hertz and 600, right? So it's really not a lot, but that is of course in the low area, right? It would of course be from here. I would expect it to be quite accurate, so this should be 800, and again we are really close. All right, this thing is what is it? It consumes 74 watts. That is a lot, and it is not affected by the output power. No, 74. That is what it is. Well, and this is the output to, oh, we get half of it. Look at that. And what if I take, so if that is half of it, if I look, yeah, I think I'll take another probe. Yeah, okay, my guess was right. So the two outputs, they're symmetric. Aha. So this is a center point. Oh, that's fine. All right, let's see. If we go all the way up, let's just crank it up maximum. 600, right? So that is 600 kilohertz. Absolutely rock steady. And this is what you get when you buy HP. That's what I'm saying. This is, they just deliver. It is absolutely fantastic. What is inside? Well, I expect everything to be amazing. So now we are inside. All I had to do was unscrew two screws here on the back and slide out the entire case in one go. So that is really easy. Look at how beautiful it is. Classic HP, super beautiful. Two high power tubes and some capacitors. I think this one is really interesting to see. So the entire capacitor arrangement here is actually tilted a little bit, and there is a shield wall here that is connected in the front, but it's not connected here in the back. So they wanted this kind of isolation to be sure that all the hum and current fields that's going inside the entire casing here is not shared with this shield wall towards the capacitors. Because if you see here, the capacitors actually go quite close to this wall, and they don't want any modulation inducted into the capacitors. So this is done by this shield wall. How cool is that? And of course we got some capacitors here, adjustments for the minimum and maximum ranges, and all the fine tuning of the entire area. That is done by flipping out a little part of the variable capacitor, so you can really make it accurate. The mechanical construction here is just amazing as always. There is some sort of an oil field mechanical. The main shaft is There's a really special feeling to it, and there's also this zero slip where there's a tension in the two gears. And here we got, of course, the oscillator parts, the two tubes and the two bulbs. Everything here is balanced, so you will see two of everything. This is the mains transformator, far away from everything. Again, they don't want to induct anything bad. Let me try and see if I can. Again, this is 9 kilos. Oy, 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 oy. So this is the really nice oscillator. And again, you'll see the two halves here with identical parts. And this is, all those are really high value resistors. See, mega ohms and whatnot. It's really, of course, because the variable capacitor here is really low value. So you need very high resistor values. And the different tappings or the different parts of the connectors here. This is actually the output that goes to the, let me see if I can get some light. So this is how the output is balanced. This is the output level. So this is simply just a double pot meter that makes the balanced output from this single-ended cable. So this shielded cable goes also to some contacts that is affected by the different frequency ranges. So of course they are compensating for more or less output depending on what range you're in, but they also use two different transformators. Look at that. So this is the low frequency range, a very big transformator, and this is the high frequency range transformator, really tiny transformator. Also we see this is the filament. So this is the 6-volt windings for all the filaments in all the tubes. And here is a sensor tap to ground. So when you turn this pot meter, you can move the AC voltage to all the tubes, and this way you can minimize hum. So this is the hum balance. Let me lift it up. Let's see the back side of the oscillator parts. This is, as always, HP beautiful. And this will be the output drivers, where you see one of the grids connected in cross. So that means when there's unbalance in the push-pull cathode followers, they will minimize drive in the other one when it's loaded wrong. How cool is that? So this is why they connected it over cross like that. And here we got all the resistors for the two sides of the drive. Oh yeah, this is of course the high voltage windings from the transformator. Look at the diodes. This is CR1 and CR2. Please look in the schematic. You will notice that in the schematic they are the other way around. That is of course an error in the schematic because we're generating a positive voltage, so they need to point this way, right? So this is a multiple capacitors in one, and then we have a very big inductor. So now we have a really nice and clean anode voltage that goes to the different tubes. And see what I said? Hum balance. And this is the dynamic balance. This is for biasing the two output stages. I can't believe how old this one is really, and then we still have those safety banana plugs. That puzzles me a little bit, because those safety banana plugs, they can't be that old. So did somebody upgrade this? Is this original? I am a little bit confused about that. Let's play a little bit with the output. So this is almost 600 ohms, and we see the two different outputs. See, if I load one output, then the other one gets much higher. It's because it is actually balanced. And see, the other output, and so on. And the fun thing is, this resistor actually gets hot. Oh, there's a lot of output power, man. I think this is by far the most powerful generator I got so far. But I really like it. It is nice and stable and a lot of output, and it's accurate. It's really accurate. The more I play with this, the more I like it. But of course it looks a lot like old funny funky tech, but come on. Have you got a generator that can do 32 volts of peak? And it's double if you if you take the output from both of them. I was playing a little bit with the supply voltage, and it's actually amazing. If I run this at 150 volts, it's only 34 watts, and I got the same output and everything is fine. If I go down to 115 or 120, the output starts to get distorted and just goes away. But look how low this is compared to the 230. Look at that. So all those watts are just heating up everything in here. And we get the same output. It's just running a lot hotter. About dating, I think the main design was from 1955. They did a few different versions, and the final design was from 65. Also, if we look at the bottom of the manual, we scroll up here a little bit, we'll see earlier versions contained a rectifier tube for the high voltage. And let's see, yeah, some different output stages and so on. I wanted to show you guys, yes, this is the entire schematic. So here is the oscillator bridge with all the different resistors for the different frequencies. Here it's easy to see how everything is done in great balance. It's a bridge, of course, so you need two of them this way, and the lamps for the oscillator drive compensation. And so that will be the oscillator parts, and then the output driver. And here we see the different output transformators for the low frequency and for the high frequency, and so they are selected via the frequency ranges. And see this trick, this is the output amplitude, and the way that they are connected with the resistors makes the output balanced. That's pretty cool. And here is the high voltage supply, and this is of course this is possible to do this to make this kind of bug when you're familiar with rectifier tubes, but you're not so familiar with diodes. Of course you would do this wrong. But so this is of course not how it is in real life. They are the other way around, and here we got the positive voltage and the filter inductor and so forth. I think this part is the output drive or the current compensation. So if you short the output, you have voltage drop here, and if you look again at the anode voltage is divided via two resistors to the two different output tubes, and look here, they are crossed. The drive is crossed, so that means if you overload one side, that one would just get less drive, and then the other one would give all the drive. And this is how you can just short one of the outputs, and then you get all the output on the other one.